Okay, ladies and gentlemen, let's talk about rates of change. Now, we just had an example of rate of change in the last video, but we want to talk a little bit more about what types of rates of change there are. There are some rates of change that are constant. That's where we're going to focus. Now, in other cases, we have rates of change that as something goes up even faster, kind of like a tractor pull. The farther the sled goes down the track, the harder it is for the tractor to pull it along. And so it just gets greater and greater and greater until the tractor can't pull it anymore. That's not really where we're going today. We're going to keep it constant, but we are going to have changing. Now, our example is a can of paint covers 400 square feet. Now, that means if I want to paint a wall 10 feet by 4 feet is going to take a can of paint. Now, we're going to make a math equation out of that. So we're going to say for every foot, or for every can of paint, it covers 400 square feet. That should give us the total number of square feet. So if I have 1 can of paint, 2 cans of paint, 3 cans of paint, or 10 cans of paint, we can tell how much it's going to cover. So we take our equation, 400x, put it up here. 400 times 1 is 400. 400 times 2 is 800. 400 times 3 is 1200. And 400 times 10 is 4,000. Okay, so now what we're talking about is this rate of change. I take for every can, it goes up by another 400 because it's 400 times however many cans. So what I can do to show this is I can graph it. Now, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Again, I'm probably not going to want to go 1, 2, 3, 4, 5, 6, 7, 8 because each can covers 400. So if I go up by 500s, that should give me a pretty good idea of what I'm going to do. Now, if I had 0 cans of paint, by the way, it's going to be 0. So let's put that on our graph. And at 1 can, I go up 400. So over 1 can, up 400. Then I go over to 2 cans, go up to 800. So again, 1 more can, 1 more 400. Go over to 3 cans, go up to 1200. And I can keep on going until I would get to 10 cans, and it's going to be somewhere up here near 1,000. So for every bit that I go over, I'm going to go up the same amount. And if I do that, that's going to make a nice straight line. So a nice straight line. This is a constant rate of change because as this goes up by 1 can, then these are going to go up by 400, 400, and on and on and on. So this constant rate of change I can put in a t-table and look at it from this perspective. I can put it on a graph and look at it from this perspective. But you'll notice in this, it's going to be over and up. This rate of change is going to turn into this concept that we call slope, or slope of a line. So we need to know, is a rate changing constant? So let me give you an example. If I have something here, and this is a monetary example, 1 for $10, 2 for $20, 3 for $27.50, 4 for $35. The question becomes, is this a constant rate of change? Well, I'm only going up by 1 shirt or pair of pants, whatever the item is, by 1 item. But in this case, I go up by $10. This, I'm going up by $7.50. This, I'm going up by $7.50. So in this case, my change is $10, $7.50, and $7.50. These are not the same. If these are not all equal, then it is not a constant rate of change like we had in the last one. And if I were to try to graph these, 1, 2, 3, 4, 10, 20, 30, 40, I would say 1 at $10, 2 at $20. Well, that's looking pretty good. 3 at $27.50, 4 at $35. I can't draw a straight line. If I just connect the dots, I start seeing this curve happening. So that if I have 5 at $41, I'm really starting to see this curve take shape instead of the straight line that I ought to see going through here. So by curving, it is not a constant rate of change.